All right, here we go. Now all the graphing stuff is done. Everything else is done. We now have to look at the algebra. But the algebra is not that bad. I think the algebra is a lot easier than some of the graphing. Well, let's look at this though. There's some advantages for each. For the graphical method, think about it. The advantage is this. It's a nice visual representation of what you've just done. You can actually see your result on a graph. That's really sweet. You can do this without a graphing calculator if you want, using the intercept method, the y equals mx plus b method. And it's fairly accurate. It's not the greatest. If you use a straight edge and stuff and not use a smart board and had too much coffee like I did with drawing lines, you'll get a pretty straight line, and it's not bad, and it's a nice quick solution. The big disadvantage of this is, yeah, it is time consuming. Look at that last podcast, which was over 15 minutes. It was way too time consuming to get this done. And again, your solutions aren't perfect. It's not exact. Well, along comes a beautiful thing we call algebra. Well, the nice advantage of algebra is that it's going to give you an exact solution every single time. You're going to get a perfect result every single time. And you've got two methods in order to do this. One is called substitution and the other one's called elimination. But the other thing here is that this is a big disadvantage, especially if you're like me and you want to see an answer. There's no visual. There's absolutely nothing. And the problem is because you don't see the visual, you might make a minor mistake somewhere and this whole thing goes right? Oh, man. So why even do it? Well, you know what? You want to do both. You want to be able to use a graphical method and you want to be able to use a nice algebraic method. Then you know the exact answer, and if you chuck it on your calculator, lo and behold, you're going to get a nice graphical representation to support your answer. That's what I tell my students to do every single time. I want you to do both. I want you to do that graphical method using your calculator or y equals mx plus b in the intercepts, whatever you want to do. And I also want you to use that beautiful brain of yours and do algebra. Okay, so the first method we're going to look at is something called the substitution method. And substitution, you're used to doing this. Look, for example, if I had 2x plus 5y equals to 10, the substitution method is very simple. I'm going to tell you x equals to 1. So x equals 1, you know to substitute. You hear the word? Substitute in for this. But now what's going to happen here is if this is an equation, guess what? This may not be 1 anymore. This may actually be 1x plus 3. So you're going to have to substitute the whole thing into this. So instead of substituting 1, you're going to actually substitute the 1x plus 3. And how do we do that? Real simple. Look, here's some nice strategies for you to do this. Step 1, always choose the simpler equation. Don't go crazy and beat yourself up by taking the more complicated equation. Try the simpler equation first and then go. And then what you have to do here is express this variable in terms of the other. So in other words, you want it as x equal to something or y equals to something. And I'll show you what I mean by that. And then here comes the substitution, which you know how to do really, really well. You've been substituting things into equations for ages. You can do that. The nice thing is, from that point, you just solve it, and then whatever's left, you're going to get a value for x, let's say x equals to 5. You're going to take this and you're going to go all the way back to the beginning here, but now you're not substituting an equation in. You're just substituting a number, and that is just going to take you very, very simple one step. You're going to get, from substituting it in, you're going to get a y value, and it's over. What do I mean? All this arm waving comes up to this point right there. Look at that. Okay, so consider the following system. Here's your system. There's it in x's and y's. Now, the cool thing is it says use the method of substitution. Rewrite the first equation in terms of x equals 2. Now, the thing is, why did I choose the first equation? Because look, that's an x. You're not going to have to do a whole heck of a lot to that. You're just going to rearrange this by saying, okay, x plus 4y equals to 17. I'm just going to solve for good old x here. And I'm going to take a 4y away. Look, take the 4y away, leaving me x equals to minus 4y plus 17. Yippee skippy. It's done, right? Not right, not quite. Look at the second equation. There's the x. Guess what? Replace that, or get this, ready for this, substitute this in for the x, because after all, that's what x equals to. So here we go. 2 times this substitution, right, goes in here. There's your minus 4y plus 17. Okay, that's going to be subtract y now equals to 7. And check this out. This equation now looks really pretty because there's no more x's. Right? You've gotten rid of one of the variables. Of course, distribute that in to give you minus 8y plus 34 minus y equals to 7. Combine like terms, you got a minus 8y and a minus y giving you minus 9y plus 34 equals to 7, and all you have to do now is solve. Subtract the 34 from both sides, right? That cancels out, giving you minus 9y, and if you look at this, it's actually really pretty because when you subtract that out, you get minus 27 here. Now divide by minus 9, divide by minus 9. Look at this. Look how pretty this works out to be. It works out to be y equals to minus and a minus cancel, giving you a positive 3. Oh my goodness. Y equals to 3. That wasn't so tough. Now, take that 3 and plunk it back into one of the original equations. And it doesn't matter which one. You can plunk it into this equation or you can plunk it into that equation. Remember, you found out y equals to 3. Now, I'm going to show you something which is cool. Instead of using these two equations, look, I solved this one for x equals 2, and that's what we want to find. Remember, that was this equation just solved. So I've got x equal to minus 4y plus 17. Check this out. All I'm going to do is plunk that in there. Minus 4 times 3 plus 17. Minus 4 times 3 is minus 12 plus 17. My answer, guess what, is, 5. So guess what? X equals to 5, and you solve your first system. And when you solve your system, since you're solving x and y, please put it as a coordinate 5, 3. Now, the big thing here then is sometimes you're going to be asked to verify this using technology. And honestly, you should verify this using technology to make sure that you've got the right answer. I know my answer is 5, 3, but I'm going to go back to my original. I'm going to go back to my original two equations, which are this. And I'm going to clean up this entire mess here so that you can see this a whole heck of a lot better. Okay, so I'm getting rid of this. Here we go. I need some room. Okay, here we go. If I'm going to use technology, I better put this guy as y equals 2. Okay, so x plus 4y equals to 17. I'm going to get rid of the x, leaving me 4y equals to minus x plus 17. Get rid of the 4 by dividing by 4, and let's get rid of all the stuff that was down here too. Okay, get divided by 4, divided by 4. Okay, that cancels, leaving me y equals to negative 1/4 x plus, look at how ugly that is, 17 over 4. Ugh. Okay, well, that's just one equation, and that's the problem with using this. Okay, if you got the one equation here, could end up being an ugly, 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 ugly fractions. Okay, well, let's look at the other equation and see if we get ugly fractions out of this. This one will be a lot prettier. Look at 2x minus y equals to 7. Let's bring the, okay, sure, we'll bring the 2x over. Bring the 2x over. That's gone, leaving me minus y equaling to, clean that up, sorry, minus y equaling to 7 minus 2x. Get rid of the y, changing the signs of everybody, so that is now 2x minus 7. Both signs are changed. There's my second equation, which I'm going to go and put in my calculator, y1, y2, and find the intersect. So our first question is negative a quarter x plus 17 over 4. Here's my calculator. Okay, negative, okay. Forgot the brackets here, so let's clear that out. Put the negative, oh, there I go again. Bracket, there's the negative 1 over 4 divided by 4, bracket x, okay, plus, again, another fraction, so bracket 17 divided by 4, bracket, okay. Down here is our other equation, which was 2x minus 7. I'm going to graph this thing. Using, of course, zoom standard if you have to, re-standardize your graph. Find the intersect by using second calc. The intersect is 5, and mouse it over. Brrr, bing, enter, 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 and sure enough, I've got 5, 3, which, if you look here then, folks, 5, 3 was the answer that I had initially for this system. So, using the algebra, actually, because you're dealing with pretty numbers and you're avoiding this kind of mess, right? Using the algebra actually works out to be quicker and more efficient than using your calculator.